My name's Dr. Rob Curtis from Australia. And good morning. I'd just like to change the title of the talk. It's actually pre-training that we're really interested in. I'd just like to emphasise that. And I'm currently with Kurtsystems now. Get this one right. Okay. Exercise and development of a young horse. Exercise is formative in the early years of a horse's life to develop the potential training traits of its parents into a powerful athletic horse. During this period, exercise stimulates bone modelling and muscle growth for strength. Exercise in the young horse is also important in conditioning the cardiovascular and pulmonary systems to optimally supply oxygen and nutrients for fitness. However, overtraining is a problem. Published statistics from studies into racehorse overtraining show around 40 to 50% of preparatory training results in a horse being retired or spelled. So this table is based on a study from New Zealand. And as you can see, this is working. It's of 3,333, which is a really interesting number, training preparations, out of which musculoskeletal injuries accounted for 834, which is 25% loss. And that breaks down into lameness, shin sore, tendon ligament problems, lacerations, fractures, respiratory problems, 5%. There were some voluntary retirements in this study, and there's a few other causes. So the body's response to bone injury is remodelling by growing periosteum fibre, which is weaker than lamellar bone. Once an injury occurs, there's a greater likelihood of repeated stress fractures in the remodelled periosteum fibre. Inadequate cardiovascular training may also result in fatigued muscles and greater likelihood of musculoskeletal injury. So injuries from overtraining in young horses whose bones are still developing, which is the focus of this talk. We're really focusing on young horses here, pre-training. Injuries from overtraining in young horses whose bones are still developing and whose muscles and tendons have yet to reach maturity can be irreversible. These horses have a short or non-existent race career if they undergo one of these injuries. So, an alternative, controlled exercise environment. What if we could exercise a young horse in a way that promotes a natural musculoskeletal and cardiopulmonary development, allowing the horse to mature while developing optimal conformation, strength and cardiopulmonary reserves, minimising the risk of musculoskeletal injury caused by intense training. So the intense training can be the problem. To achieve this goal, a natural controlled exercising environment is required that encourages the young horse to develop during this pre-training period. I just wanted to emphasise the word natural. So I've done lots of treadmill studies in Australia and Japan and discovered the inherent limitations of applying the understanding of what we get from a treadmill onto a real track situation. So you have a much harder surface and different gradients, so different gaits imposed. If a young horse were not weighted by a rider whilst pre-training, but could still do moderate exercise in a structured regime, this would allow the development of optimal fitness while minimising the risk of musculoskeletal injury. Okay. Aerobic exercise. case for aerobic exercise for both the horse and human is clear. Routine exercising at only moderate aerobic levels, so we're talking about heart rates of 80 to 150 in an equine case, have been shown to strengthen the respiratory and cardiac muscles, improving air and blood transport efficiency, improve circulation efficiency, increase the number of red blood cells, improving oxygen transportation, and neovascularization of the muscle sarcomeres, increasing muscle blood flow, increasing the rate at which aerobic metabolism is activated within muscles, allowing a greater proportion of the energy for intense exercise to be generated aerobically. Improve muscle use of the fats during exercise, preserving intramuscular glycogen for anaerobic activity when we eventually arrive at that point. Enhance muscle recovery rate, and there's a whole bunch of others. So this is one good place where we'd like to start exercising horses for a gentle start to life. Track surface. If the horse were exercised on a consistent and low impact surface that allows the dissipation of shock energy into the surface, so it's a yielding surface, rather than absorbed by the musculoskeletal structure of the horse, that's got to be a bonus. Research shows a horse can withstand 80% more impact shocks, which are steps, on a yielding surface than a firm one, before cumulative musculoskeletal stress may cause injury. Okay, so the big question is, what is equine athletic fitness? Why do we want to achieve, what's our focus, what's our goal? So in a controlled exercise environment, so this is our dream, we want to train these, we want to do pre-training in a very controlled way. Monitoring the fitness of the horse during exercise and recording physiological fitness indicators for the regime would provide invaluable management information to gauge the horse's health, welfare and maturing process. A quick review of what we mean by fitness for the athletic horse. So nutrition, is that appropriate for the demands of the horse? Cardiovascular, is the heart and vasculature able to deliver oxygenated blood to the muscles at peak demand? Respiratory, is the respiratory tract and lungs able to bring in sufficient oxygen and expel CO2 to meet the metabolic demand of the muscles? Musculoskeletal, which is obviously part genetic and part training. Can bone structure and muscle development be nurtured by careful welfare and training for optimal locomotion? So for the best prepared athletic horse, owners and trainers will look for optimizing all these things. I'd like to sort of return to fitness monitoring a bit later in the talk. But now we come on to an example, a working example of what a controlled exercise environment might look like. If I can get the right button here. Okay, so this is Kurtsystems monorail is a controlled exercise environment for pre-training young horses. Now, this is in Lambourne, West Berkshire. So about an hour when there's not terrible traffic on the road from here. So it consists of an all-weather track of 6 furlongs in length, 2 straights of 2 furlongs, and 2 curves, each of a furlong. We don't have furlongs in Australia. They don't make any sense to me. The track's sand, geotextile and wax aggregate is used in Olympic jumping and 3-day events. This is a very yielding surface. So I'd just like to present a little, now, is this going to work? Video of what this is going to look like. And it doesn't work, which is always good. Okay. Okay, I think your computer has a problem. Here we go, right. Sorry about this. So this is aerial view of the track. Up to 10 horses may be exercised at once using a low stress, no rider load method. The horses are brought into yokes. There's 10 of them in pairs, 5 pairs. It's a very calm environment, so and the emphasis on calm horses. Each of the cabins has a handler that can assure the horses as they're walking. So at the front of each of the yokes is a gate system to enclose the horses, and then that swings away during exercise. So the monorail is driven at a required speed profile for a particular exercise, as we set. So we can have, for example, a warm-up period, some walking, some trotting, sustained canter, and then a cool-down period. Now, as you can see, this is kind of a pretty unique situation that it's a very controlled environment. There's a beautifully prepared track that's a totally yielding surface, very calm environment for training young horses. Plenty of opportunity to do lots of physiological measurements that will help with management of horses and studying them. So at the back of the whole system is a control cabin with the driver in it, able to deal with any problems that might arise. And I think that's the end of that bit. So young horses using this Kurtsystems idea of pre-training, we have a schedule of step 1, acclimating horses to the equipment. This usually takes between 2 days to 7 days. Most horses really acclimate well to this equipment. It looks pretty scary to most people sort of walking up to it, but it's quite amazing that once a horse is actually attached to the equipment and walking starts, there really isn't a problem using it. In fact, I've been on experiments where Danielle, the trainer involved, and myself actually pretty much put a horse on, and straight away it was fine. It's about reassuring an animal, being very calm with it. Step 2, so after we're quite satisfied the horse is acclimated to the equipment and comfortable, we just start with a couple of days a week of walking, trotting, walking. So we have a walking warm-up period, a little bit of gentle trotting. They get used to exercising on it. Then we move on to the real work, which is a 3-month period of gradually increasing the number of days a week that the horse exercises, also increasing the distance of the exercise and the speed. And at the end of the 3-month period, we end up with this goal of 1 mile walk, 1 mile trot, 1 mile canter, 1 mile walk. And the maximum canter speed can be between 20 and 35 miles an hour. So these horses are not breezing, I believe the American word is. These are very calm, sub-maximal exercise to improve, well, it's all aerobic exercise to improve bone growth in a very gentle way. Step 3 is no load, so there's nothing on the horse's back, no rider, no saddle. Step 4, we gradually introduce weight onto the horse, and we pretty much repeat step 3. We start slowly, and gradually over 3 months we increase the saddle weight to 35 kilograms, we increase the speed until we arrive at this 1 mile walk, 1 mile trot, 1 mile canter, 1 mile walk. At which point we're reasonably satisfied that the horse is getting to the point of maturity. It's now able to handle the weight, and then we can go on with normal training. The thing that we're asked a lot is safety features. So we're strapping horses into this monster machine. I've done a lot of training on treadmills, and this is so much safer. So for instance, this has a pointer, doesn't it? There you go. We have quick release Bowden buckles, so the horse is firm in the system, but it's able to be let out if emergency happens. The gaits are restrictive. That's all controlled as to the horse's position. It's impossible for the horse to actually fall and hit the track because of the way the cradle, the girth cradle is actually designed, which hangs in the machine. There's little red mushrooms as a safety stop features everywhere. There are many other safety features built into this, and it's actually very safe for both horses and for humans operating the system. So now I just wanted to go back to actually measurement of fitness. We've now got this complete controlled and safe exercise, which is, from an engineering point of view, that's the load on the physiology. So now we need to measure the physiological response to that load. So we want a system that can measure day-to-day or period. So we're talking about data storage of large amounts of data. Back to the big data story that we've just heard of from the previous speaker. We can use this as a herd management tool, as a proactive welfare and health indicator for each horse, also as a research tool to fine-tune this pre-training system, and also there's a lot of veterinary research we can do on this machine because it's such a controlled exercise regime. So the factors that affect performance: inherited factors, environmental factors, training factors, management factors. Some of those things we obviously can't control, many of them we can. In order to do our measurements, we're looking for an ambulatory measurement, so something which is lightweight, can be fitted to the horse easily, non-invasive sensors preferred, real-time data gathering, wireless telemetry, so there's no wires actually attached to the animal. This also allows for a safe and simple operation. I should just step back a bit and say that I'm currently involved in the design and implementation of these biomedical systems on this machine. We're still in the installation process. So a lot of the things you'll see in the next couple of slides are either already built in or they're about to be built in. We have a semi-automated identification of a horse, so there is a system where you can scan a microchip from the horse and it will be saved along with all the data and telemetered back to the main database, so we can identify which horse is in which yoke and what its performance is. Once you've recorded all this information, well, in real time, we have the possibility of actually monitoring important parameters in order to modify the exercise behaviour. So sometimes heart rate might be an indicator that you really want to know about as it's happening to be proactive. Most of the data you're not really interested in real time. It's all stored in a big database for post-analysis. So first thing is obviously cardiovascular fitness. We're looking for heart rate. There's some very reliable measures of fitness in heart rate. We won't be using heart rate max for this because we're sub-maximal exercise. Respiratory fitness. So some horses, but not all horses, will occasionally be presented with a respiratory fitness measurement, which is a mask, which you'll see in a tick, which will measure basic flow rates, tidal volumes, breath frequencies. And here's some mask work that I did before. So horses fitted with a mask. This is on a treadmill. This is on a track with a similar device to the Kurtsystems as a previous generation. And this is acclimating the horse to the mask. So it didn't actually have and this central one, didn't actually have the flow sensors on it. We just acclimate the horse, make it quite happy with the use of the mask. These are low respiratory resistance devices, so it's just like normal breathing. Here we have some data that came from a test in Japan, I think this one was. So this first trace shows the flow rates, respiratory flow rates. This horse is exercising at 7 meters a second and shows its tidal volumes, breath frequencies. From this we can look at the respiratory fitness of the animal, how it responds to exercise. There's some automation built into this whole process, so we can actually zoom in and take a look at a couple of respiratory samples and actually do some more in-depth analysis. This is the sort of data that you would get in a human pulmonary laboratory, which is, it's fairly in-depth information. Motion muscle thickness. So now we're talking about gait analysis. There's two approaches to this. One is attach a sensor to each leg, and a second approach is a single sensor looking at whole body movements. Different people have used either a combination or one or other. At the end of the day, we're not looking for hugely in-depth information at the moment, but hopefully as research progresses we will be. Another thing that's not really thought about too much is behavioural fitness. How does a horse behave in such a piece of equipment? In fact, how does it behave on the track? Because a race-fit horse is as much a behavioural fitness as a physiological fitness. In fact, it's very difficult to separate behavioural fitness from physiology. If you have a startled horse, you have a very high heart rate and a lot of other responses. I just wanted to have a very quick review of general monitoring technology. So why is it now that we can do this? Well, there's a lot of large companies that invested a huge amount of money into mobile phone technology and all the little sensors that are involved there. There's a big interest in human exercise monitoring, as we've just seen on a previous talk. There's a lot of convergent functions, lots of sensors built into a single device which is able to communicate. And a lot of that technology is now available for us to start applying into the equine market. So these are the technological things that should be exciting everybody, that maybe as some of you equine people are see in the background. But so microprocessors, they've become smaller, cheaper, low energy. There's lots of really nice power sources now with huge energy supplies. On horses for long distance, it's now possible to harvest power and not actually have any batteries on board from the movement. Sensors, gait analysis sensors are using MEMS technology. which is a micro-machined, micro-electromechanical system. So you're actually able to machine pieces of silicon to do mechanical things and then attach electronics to the back of that. So we can get some really quite sophisticated function out of that. Acceleration, gyro, magnetometers, pressure, sensors, temperature, humidity, etc. And these are all nice low-cost devices which can be integrated into things. 3D printing has really changed the way we're going to be able to build monitoring systems onto horses. We can do shapes that we couldn't build before easily. Low energy wireless networks, how do we get the information from an animal safely? The Internet of Things, how do we control big networks? So in this particular, on the monorail we have 10 horses, bristling with sensors. There's something like, I think there's about 16 or 17 data channels per horse. So that's 170 points of information coming out once every 20 milliseconds. It's a lot of data. How do we handle all that data? And database technology, what do we do with the information and access it afterwards? And also solid state disk drives have been fantastic. Anybody that's got a computer with a solid state disk drive knows that they can press a button, it will start up immediately. It means there's faster, more robust storage, which is enabled to handle all this data. Now then, as I say, this is a quick hand-waving review of the whole process of the future of monitoring. So we need to put more energy into analysing the signal processing. What do the squiggly lines that I've just showed you really mean in terms of physiology? How do we extract some of the indicators? Some of them have been well studied: heart rate, respiratory function, gait. One of the things that I've found particularly fascinating is the combinations of these numbers. For instance, in the horse, stride and respiratory function are coupled during galloping. So if you measure more than one thing at a time, you get a lot more information. More clinical research and engineering research is really needed in a lot of these areas. And some of the useful technologies to do this sort of analysis: digital signal processing, classifiers, neural nets, big data, and a lot of epidemiology. So, as was mentioned by a previous speaker, we need a lot of numbers from big populations to really get the best out of a lot of this equipment. And I think the questions are delayed to some other event, so we'll pass over that slide. So basically, I want to just acknowledge Mr. Kurt for his insights into putting this whole thing together, and Mr. Daniel Knufo, who's a trainer and world expert, I'd say, in training. So thank you very much.